So here we are asked to prove that the sum of these two fractions gives you the expression on the right, 2 tan theta secant theta. So it's an identity rather than an equation, so we should work with what we have on the left-hand side and try to make it look like what we have on the right-hand side. So we'll start by trying to add these two fractions. So to add fractions, you need a common denominator. The common denominator will be the product of the cosecant minus 1 times cosecant plus 1. So let's write that the long way. So cosecant theta minus 1 times cosecant theta plus 1. And in the numerator, we'll have cosecant theta plus 1 plus cosecant theta minus 1. So I've simply added the two denominators. So I've taken a common denominator and then added. So now you'll see that this positive cancels with the negative, and we have 2 times cosecant theta divided by, you'll notice that this gives you the difference of two squares, so cosecant squared theta minus 1. And that looks nothing like the expression on the right. So remember, where have we seen cosecant squared before? You will remember there is an identity that we can manipulate. Remember, sine squared theta plus cosine squared theta gives you 1. And if you divide each of these terms by sine squared, that will give you 1 plus cotan squared theta equals cosecant squared theta. And if you rearrange that, you can find cosecant squared theta minus 1 is equal to cotangent squared theta. And that's exactly what we have in the denominator. So we've got cosecant squared theta minus 1. So so we can replace cosecant squared theta minus 1 with cotangent squared. So now my expression looks like 2 cosec theta divided by cotan squared theta. And that still looks nothing like the expression on the right. But remember, cosecant is simply 1 over sine, so that's 2 times 1 over sine theta. And cotangent squared is sine squared over cosine squared. So when you divide by cosine squared over sine squared, that's the same as multiplying by the reciprocal. So that's sine squared theta over cosine squared theta. And that sine theta will cancel with the squared, and 1 over cosine squared is simply secant squared. Or maybe that's not the best thing to say. I should say sine over cosine is tan, and 1 over cosine is secant. So you end up with 2 multiplied by secant theta multiplied by tan theta. And that's what we were asked to find in the question. So that's your final answer, and that's how you would show, or that's how you would prove this identity.